This is Aldo Contreras. I'm going to talk about our work named Soft Wearable Device for the estimation of shoulder orientation and gesture. We're working at the Universidad Politécnica de Madrid on the Center of Automation and Robotics. My colleagues are José Luis Samper Escudero, David Ponte Esteban, Francisco Javier Sáez Sáez, Miguel Ángel Sánchez Urán, and Manuel Ferre. There have been many attempts to identify the movement of the human body in a virtual way by monitoring the behavior of the extremities for haptic interfaces, teleoperation tasks, and assistive and rehabilitation devices. Robots increase the number of repetitions performed in a rehabilitation session, thus improving patient morale and motivation. In recent years, rehabilitation devices use electromyography as main source of feedback for control. Several electromyography techniques are used for identification and classification of movements. One powerful tool for the classification of operator movements is the convolutional neural network. These methods, combined with appropriate signal filtering techniques, are useful for estimating the movement of the human body. This paper focuses on the development of a soft compressive jacket. It has a network of soft flexion and electromyography sensors for movement detection of the upper limbs. This device allows the user to quickly start estimating shoulder orientation without the need of prior calibration. We experimented that using a configuration of 7 one-axis sensors, it is possible to obtain the 95% of the variance of the principal components for the shoulder gestures. The configuration proposed in this paper places only an array of 4 flexion sensors in the intermediate positions since they provide flexion measurements in 2 axes. To identify the user activity, 3 electromyography sensors are placed over the muscles. The method developed in this study was evaluated in 4 healthy subjects. Tests were spread over 3 different days to avoid fatigue of the muscles. Each subject performed a total of 5 repetitions of each of the 5 gestures continuously without interruptions. To start data collection, the electromyography and flexion sensors on the compression jacket are placed on the subject's right arm. Then, OptiTrack markers are located to obtain the real pose. Both sensors are connected to a custom acquisition board. The OptiTrack system stores the position of the markers. In the end, both files are merged into one using the timestamp. A graphical user interface has been developed to guide the speed and kind of movement of the participant while performing the gestures and to log all obtained data. Data processing. The angle between the markers is obtained by calculating the angle between the arm markers on the shoulder and the vertical markers on the chair. A time series network is used to calculate the orientation of the arm using the angles given by the flexion sensors as input data and the OptiTrack markers as target. A classification of gestures is made. ID numbers are assigned to each movement and dummy variables are used. This to recognize patterns from the signals from both sensors. For the estimation of the orientation, 2 time series network configurations were designed, one for the dummy variables and one for the gesture numbers, resulting with a minimal difference on mean square error and regression value. So, both can be used as an offline prediction method. To evaluate the trained network for both orientation and gesture, a new single session is performed by one of the original subjects. For gesture classification, a pattern recognition neural network is designed. To verify that the fusion of the data is feasible, 3 different networks are trained. One network only with the EMG data, another only with the flex sensor, and the third with the 2 of them. The network using only the EMGs shows poor results for this application. Meanwhile, the flexion and the combined networks both have promising results. It could be said that the flexion sensors are sufficient for the classification of movements for a certain type of applications that do not require great sensitivity, while the fusion of both sensors denotes a great performance with minimum error. Thank you.